This is a greenfield ride-on mower. Known for their simplicity, robust construction, repairability, and performance in tough conditions, the brand has its own cult-like following. But like most ride-on mowers, it's powered by an internal combustion engine. To me, this is its Achilles heel. The fuel is expensive, it emits carbon dioxide and other pollutants, you breathe those pollutants in as the user, it's loud, and it relies on complex mechanical parts that are prone to failure and often difficult to repair economically. Just ask anyone who's owned one for any length of time. I always believed this machine could be so much more were it free from these pains. And after completing a degree in electrical engineering, I decided I would take it upon myself to do this task. Don't get me wrong, I'm not really an electric vehicle purist. I don't believe the lithium grows on trees, and I don't wish to imply that anything I'm doing here actually has a net environmental benefit per se. But I know what the future is, and I wanted to create a little piece of it right here in rural New Zealand. So this is my project, Project Greenfield Electric. They say you can't make a cake without breaking eggs. Likewise, the first part of this project required me to destroy a good mower for science, by removing all of the parts that wouldn't be needed to operate it on electricity. Admittedly, it was a 20-year-old good mower though, and conveniently, the main point of failure was the very engine that I was getting rid of. Getting rid of it proved a little tricky though. Haven't lifted one of these for a while. Do you reckon I can still do it? I don't know. Pretty heavy. Good is it? What is going on down there? Something getting in my way. There we go. That's not too bad. With the engine out, the existing electrical system removed, and the crud cleaned away, the next step was to modify the chassis to house an electric motor in place of the original clutch assembly. My plan was to use brushless permanent magnet AC motors with speed and direction control, with one driving the wheels and another spinning the blades. While the Greenfield clutch assembly is a mechanical masterpiece of simplicity, the beauty of this type of electric setup is that you simply don't need a clutch at all, and removing it makes space, improves efficiency, and it means I don't have to fix the damn thing. I removed the original mounting points for the clutch, and I cut a hole in the chassis so that the wider electric motor could fit where I wanted it. I used a Mott Energy ME1718 electric motor, which is sealed and convection cooled, so it won't get filled with grass cuttings over time and catch fire. My process for breaking apart welds involved angle grinding away the majority of each weld and then using brute force to break the remainder of the weld and straighten out the chassis afterwards. A hammer was involved. Done. Next, I fabricated a new 4mm thick steel plate to mount the motor on. It was cut to size such that it could be welded straight onto the chassis in multiple places. Then, with a large hole for the motor shaft and 4 smaller mounting holes, the motor would bolt onto the plate with its shaft driving a sprocket and chain to the existing rear axle and differential unit. This provides a gear ratio of about 7:1, meaning I didn't need a gear reducer. Now you might have assumed that I would use one of the many commercially available motor controllers out there, but actually I built my own. All of the commercially available products come with their own limitations, and most of them come at an exorbitant price. The leading option for my usage, the Sebcon Generation 4, also locks you into an extremely restrictive software contract in order to program them yourself. I'm an electronics engineer and I wasn't having a bar of that. By building my own controllers, I literally saved money, even though I was building only 2 controllers for a one-off prototype machine, and the time I spent in the design phase would have been more than worth it for the education alone. I developed software functions to replicate the original driving behavior of the mower. Previously, it had clutch plates that responded to the force of the user's foot on the drive pedal. I replaced those with force sensors to detect forward and reverse pressure from the drive pedal, and thus control the torque applied by the motor and its direction. This also allows regenerative braking. Speed limiting is also possible, but I haven't really bothered with that. It was eventually time to start actually driving it. As you can imagine though, early testing was somewhat problematic.
You can hear that noise out there, right? All those lawnmowers. Okay, watch this. Don't really know why I'm doing this, but that's just how these things tend to go sometimes. Because now, we're going! Holy didn't really intend to go this far, but I think I'm going to be able to get back up the hill because I don't have much torque. See, that's all I got. I can slow down, but I can't actually go back up the hill. Oh, did that just cut out? Yeah, it did. Right, I'm going to have to push this back to the shop. Bit of a disaster, really.
Subsequently, things began to improve. Well, not that much.
Bump this time. Yeah. Yeah. It goes. It's looking promising. It's only, 1 in the morning. I think I'm going to go down the car park. See if it holds that long.
finally. I demonstrated fairly early on that it could easily tow a trailer loaded with wood, lead batteries and the old engine up a mild incline, satisfying my initial concern that it wouldn't have enough torque to do useful things. And that's when I discovered how fun it was to go fast.
3, 2, 1.
My lack of a gear reducer means that it has a theoretical top speed of about 70 kilometers an hour. I was then ready to work on the next stage, the bit that spins and chops the grass. I used another Mott Energy ME1718 motor, and rather than coupling it directly to the blades, I opted for a belt drive to avoid the need for custom mechanical couplings. I thus fabricated another motor mounting bracket, and also used the original tensioner parts from the mower to make a new belt tensioner. Welding was a big part of this project. This isn't an aeroplane, and over the years I've learnt to stick weld well enough to hold things together. But it's still a nice surprise when my welds come out looking good.
Okay, what's the bit? This is a good one. There you go.
You might argue that belts are highly undesirable and hence usually avoided on electric equipment. But having a belt would save the motor in the event of hitting something nasty, and when you're cutting grass, that happens. Since this belt is B-section, quite short, and has no backbends or twists whatsoever, it's also going to be substantially more reliable than the belt drives you typically find on garden equipment. And it's all easily fixable with generic parts from any engineering hardware store. The last stage of installing the cutter assembly back onto the main chassis was to cut a circular hole in the chassis so that the cutter motor would fit in. Then the question was, would it all fly apart when I turned it on?
Terrifying, honestly. Oh wow. It does go.
As it turned out, it didn't fly apart. In fact, it ran pretty much perfectly. For once, something just worked.
Just want to remind everyone, this is the first test run. And there's one thing I've got to say, I'm amazed about is how smooth that actually is. Wow.
Having established spin, I wanted to try and cut grass, but I had a problem. I hadn't yet assembled a second motor controller, and I was too impatient to just get on and do it.
Piece of wood.
So with my one and only controller spinning the blades, I had to pretend the whole thing was a giant push mower. But it worked. I then got hold of the parts I needed and got on with assembling the second controller. I believe I soldered for approximately 10 hours in one day, which is absolutely ridiculous. Don't do it, you'll regret it. I then spent the next morning testing the assembled hardware to make sure everything worked like the first controller, and welded together some framing to mount the controllers to under the seat area. Then it was ready to test.
Join me for the first time to see what it does. My ridiculous creation. Okay, 1000 RPM, very slow, starting up. That's pretty piss poor. We double that.
And there it is. Now that was all well and good, but I was powering the thing from the world's most ridiculous battery setup.
Well folks, I think this dodgy, bodged up battery setup has done pretty well. Proved some important things. Melted a few alligator clips, such as that one right there. But I think the time has come to replace it with something better.
I decided to use lithium iron phosphate cells as they're easier to deal with and somewhat less likely to catch fire than other lithium chemistries. I used 24 3.2 volt 105 amp hour cells, which I imported from China by sea, because nobody was selling them in New Zealand for a reasonable price at the time. The total capacity is around 8 kilowatt hours. They're prismatic cells, which basically means they're rectangular shaped and can pack together inside a rectangular frame. So I made a battery enclosure, again from welded steel. The cells are insulated from the frame with a layer of rubber on all sides, and the frame is designed not to flex as you drive the mower over bumps, so the cells don't get mechanically stressed. The batteries can discharge at 8 kilowatts continuously, or up to 24 kilowatts for a couple of minutes. My motor controllers and the motors can do similar numbers, and these are the sorts of numbers that scare petrol mowers, because 24 kilowatts converts to 33 horsepower.
I guess most people wouldn't call it pretty, but it should work. It should be pretty good. Basically, they're all in series. It goes like this, and then it jumps over to here, and then it goes like that, and then it jumps over there and goes like that to the negative. And I just wanted to film it briefly in case it burns when I turn it on.
Nah, just kidding. And there it is running properly at last. Kind of underwhelming, right? I mean, all it does is move around and chop up small plants. Did I really spend all those months for this? No, I didn't. After installing the final battery setup, which could supply a lot more power, it became clear that I had created something interesting. Many electric ride-on mowers already exist, but compared to petrol, their power and runtime sucks. For me, the aim of the game had changed. Don't just make it electric, make it better than petrol. I promise you'll never see a lawnmower go this fast. The coast is clear, I think. Please do not try this at home. But if you do, for God's sake, wear a helmet.